Okay, so here's the second video on Lagrange multipliers, and what we're doing in this case is making it a little more general. So what I'm going to do in this case is use the same Cobb-Douglas utility function that we had before, but instead we're going to have, instead of having specific numbers, we're going to use I, Px, and Py. When we solve the problem in this case, in this form here, we're going to get demand functions, okay? So we're going to apply this here and solve, and go to solve it. And we take the partial derivatives with respect to x. And then you're going to have the partial derivative with respect to lambda is going to give us the budget constraint back. This is a relatively small board, so I'm not going to rewrite that again because otherwise I might run into a lack of space. So again, you have three equations, three unknowns. It's algebra. You solve it however you want, to whatever works for you. Again, I'm going to take this first one here and solve for lambda. And so then I have to divide through by p. So now I'm just going to do that. And so I get this for lambda. And now we can come in and substitute for lambda in our second equation here. I'm sorry, I started doing this way. Oh, not lambda, we have py. Here, what we can do is multiply both sides of this equation by x to the 1/2, y to the 1/2. So multiplying both sides, we've got 0 over here, but you've got to distribute the x to the 1/2, y to the 1/2 out here, and that would end up giving us 1/2 x. Py and then if you rewrite this here, you're going to get that x is going to be equal to the 1/2 will cancel. And then you've got to substitute this into the budget constraint. Actually, I'm going to write this over here so I have a little more space. Substitute this for x in the budget constraint. And then what you'll see is those px's cancel. You're going to end up with and then if you rewrite this, you'll get y is equal to I over 2 Py. It's right there at the bottom there. We're not quite done because we have an expression for x here in terms of y. That's not the solution. That's not a demand function for x. We have to substitute for y here. And then what we'll get is, writing it this way, x is going to be equal to I over 2px. And so again, when you do a Lagrangian with a specific utility function, but just with px, py, and I, what you'll end up getting is what these things are here, and these are demand functions because you can plug in any value of I or py and px, and that would be what gives you the numerical value for x or y that would solve the problem. So this is a second take at Lagrangians, and you're getting a little more abstract in that we're using more symbols as opposed to numbers. You're not going to get a numerical solution, but you can get an exact solution with the demand functions. So a big part of what we're trying to do in this class is get you more comfortable being able to do stuff with symbols as opposed to just numbers where you get numerical answers, and this is a step toward that.